We live on a planet that feels safe. Blue skies, oceans full of life, air that quietly keeps us alive. But Earth is protected by something we cannot see, an invisible shield that stands between life and the violence of space. It is called Earth's magnetic field, and in this story, that shield disappears. Not in millions of years, not slowly, but suddenly. Deep beneath your feet, far below the surface, Earth's core is alive. A massive ocean of molten iron rotates around a solid inner core, generating an enormous magnetic force. That force stretches far into space, forming a protective bubble known as the magnetosfera. It deflects charged particles from the sun. It shields our atmosphere from being stripped away. It protects every living cell on this planet from lethal radiation. Without it, Earth would look very different. Mars once had a magnetic field too. When it lost it, its atmosphere slowly vanished. Oceans dried up, surface radiation increased, and the planet became cold, dry, and lifeless. Earth survived because its shield remained. Until now. In this scenario, Earth's magnetic field collapses. There is no explosion, no sound, no visible warning. But within minutes, technology begins to fail. Satellites experience severe interference. GPS systems drift off course. Communication networks become unstable. Across the planet, the sky begins to change. Auroras, normally confined to the polar regions, spread across the entire world. Green, purple, red, dancing lights fill the night sky. Beautiful, unnatural, and deeply dangerous. Because those lights mean one thing: the sun has direct access to Earth. The sun is not calm. It constantly releases streams of high-energy particles, a phenomenon known as solar wind. Under normal conditions, Earth's magnetic field deflects these particles, guiding them safely around the planet. But now, nothing stands in the way. Solar wind slams directly into the atmosphere. Molecules of oxygen and nitrogen are struck, energized, and slowly pushed into space. Not all at once, not dramatically, but continuously. Hour after hour, day after day, Earth's atmosphere begins to thin, exactly the way it once happened on Mars. As the atmosphere weakens, another threat arrives: cosmic radiation. High-energy particles from deep space begin reaching the surface in unprecedented amounts. This radiation does not kill instantly. Instead, it damages DNA. Cancer rates increase worldwide. Genetic mutations become more common. Human fertility begins to decline. Air travel becomes dangerous. High-altitude flights are canceled indefinitely. Astronauts can no longer survive in orbit. The children are affected the most. The planet is still alive, but its future is already collapsing. Animals sense the change before humans fully understand it. Birds lose their ability to navigate. Whales strand themselves along coastlines. Insects die in massive numbers. Plants begin to mutate under increased radiation. The food chain weakens. Large animals disappear first, then ecosystems unravel. As the atmosphere thins further, temperature extremes increase. Scorching heat during the day, freezing cold at night. Earth is no longer stable. It is becoming hostile. There is no final explosion, no dramatic extinction event, just a slow loss of air. Oceans begin to evaporate. Water vapor escapes into space. The sky fades from blue to black. In the end, Earth becomes a dry, cold world with traces of a once living planet. A second Mars. The most unsettling truth is this: Earth's magnetic field is not permanent. It has weakened before. It has shifted. It has even flipped. Today, it still protects us, and because of it, you are breathing. You are alive. All thanks to a shield you will never see. And that is the problem, because we treat invisible protection as if it is permanent. A magnetic field feels like a fact, like gravity, like the sky, but it is not guaranteed. It is a process. A machine made of molten iron running deep inside the planet. And machines can change. The field has weakened before, not once, many times. Sometimes it shifts, sometimes it fractures into multiple poles, and sometimes it flips completely. North becomes south, south becomes north. This is not theory, it is recorded in stone. Volcanic rocks cool, and tiny magnetic minerals lock in direction, a fossil memory of where the planet's field once pointed. A reversal does not mean the shield vanishes forever. But it can mean something else: instability. For a period of time, the magnetic field can become disordered, weaker, uneven, more like a shield with holes than a solid wall. And during that window, space does not become gentle. If this happened today, it would not turn Earth into Mars overnight, but it could turn modern life into something fragile. Power grids would be at risk, satellites would fail more often, navigation would degrade, radiation exposure would rise, especially at high latitudes and high altitudes. The danger would not be one global flash, it would be a series of failures that arrive faster than systems can adapt. And the deeper truth is this: we are not only protected by the field, we are also dependent on it. Our technology is built under its umbrella. Our biology evolved under its filter. Even our atmosphere, the thing you breathe, exists in the shape it has because this shield has been there for most of Earth's history. So the question is not whether the magnetic field can change. It can. The question is how much change can our world tolerate before normal life becomes impossible? Because the most dangerous shield is the one you forget exists, and the most frightening disaster is not the one you see coming. It is the one you never learned to notice at all.